What if the future of space exploration could be powered by nuclear reactors? Have you ever imagined that? As we set our sights beyond our home planet, one of the biggest hurdles we encounter is energy. We need it for life support, for scientific experiments, for mining operations, and so much more. And with the space race heating up, the moon is our next big frontier. But the moon's environment is not exactly conducive to conventional energy sources. Its 2 weeks of nighttime and a near non-existent atmosphere make wind and solar power an unreliable bet. So, what's the solution? Nuclear power. This might conjure up images of massive power plants, but over the decades, nuclear technology has become increasingly compact, capable of delivering loads of power in a small package. This makes it a prime candidate for powering our lunar ambitions. And it seems Russia and China are on the same wavelength. Their respective space agencies, Roscosmos and the Chinese National Space Administration, have been eyeing a collaboration to put a nuclear reactor on the moon. This announcement was made by Roscosmos' CEO Yuri Borisov during the World Youth Festival in Sirius, Russia. He stated, "Today, we are seriously considering a project to deliver to the moon and mount a power reactor there, jointly with our Chinese partners somewhere between 2033 and 2035. The reactor is intended to be part of a joint operation on the International Lunar Research Station, a scientific base on the lunar surface. This station, announced in 2021, is set to be established in the 2030s, with precursor missions continuing throughout the 2020s. The reactor, Borisov assures, can be fully automated, requiring no continuous human presence at the station. As the space race accelerates, the moon is becoming the stage for some of the most ambitious energy projects ever conceived. So, buckle up, because the dawn of lunar nuclear power is upon us. When two global powerhouses come together, the results can be astronomical. This is precisely what's happening as Russia's space agency, Roscosmos, and the Chinese National Space Administration, or CNSA, join forces in a monumental endeavor. They plan to bring nuclear energy to the moon. This isn't a mere notion or a lofty dream. It's a concrete plan with a clear timeline. Roscosmos' CEO, Yuri Borisov, unveiled the project at the World Youth Festival in Sirius, Russia. He shared that the joint venture with their Chinese partners aims to deliver and install a power reactor on the lunar surface between 2033 and 2035. But this isn't just any reactor. The technology behind it enables full automation, eliminating the need for continuous human presence at the station, a truly remarkable feat of engineering. This lunar nuclear reactor is a key component of a broader collaborative effort. Russia and China, along with a handful of other nations, are working on the International Lunar Research Station, or ILRS. This station is set to be a scientific base camp on the moon's surface, a hub for innovative research and exploration. The ILRS was first announced back in 2021, with its establishment projected for the 2030s. This timeline aligns perfectly with the planned delivery of the nuclear reactor, creating a synergy that could potentially accelerate the mission's progress. The groundwork for the ILRS is already being laid, with precursor missions continuing throughout the 2020s, not unlike NASA's own Artemis missions. This lunar nuclear reactor is more than just a power source. It's a symbol of international cooperation in space. It represents a shared vision of the future, where nations unite in the pursuit of knowledge and exploration. The partnership between Russia and China demonstrates that when it comes to conquering the final frontier, we're stronger together. The idea of nuclear power in space is not a new one, and it has a fascinating history. If we turn back the pages to the mid-60s, we find NASA launching the first nuclear reactor in space, known as SNAP-10A. This marked the beginning of an era where nuclear power was seen as a viable solution for long-term space missions, especially those involving human presence. In the following decades, NASA's interest in nuclear power only grew, culminating in the initiation of the Kilopower project in 2015. The Kilopower project was an ambitious endeavor aimed at designing nuclear-powered technologies specifically for spacecraft and potential lunar operations. It was a clear message to the world that NASA saw nuclear power as a key component of our extraterrestrial future. By 2018, NASA had announced that the Kilopower project mission was complete. This successful completion was a testament to the potential of nuclear power in space, and it set the stage for NASA's next ambitious project. The agency then shifted its focus to what is known as the Fission Surface Power Project. This new project aims to create a system that weighs under 6 metric tons and can deliver 40 kilowatts of power. To put that into perspective, NASA claims such a system could reliably sustain 33 households for a decade. That's a small town on Earth or a significant lunar base. As of 2024, NASA announced that the first phase of the Fission Surface Power Project was complete. The next phase, set to begin in 2025, has the grand objective of creating a final reactor design for testing on the Moon. This ongoing commitment to nuclear power in space shows that it is far from being a relic of the past. Instead, it's a critical part of our future in space exploration, powering our dreams of establishing a human presence beyond our home planet. Nuclear power has been part of our space exploration journey for decades, and it's not going anywhere soon. While China and Russia set their sights on the Moon, NASA has its own nuclear ambitions. In the pursuit of sustainable extraterrestrial energy sources, NASA has been working on an innovative project known as the Fission Surface Power Project. This ambitious endeavor aims to create a nuclear power system that is not only compact, but also powerful enough to sustain lunar operations for extended periods. The project's goal is to develop a system that weighs less than 6 metric tons, yet capable of delivering 40 kilowatts of power. That's enough to reliably sustain 33 households for a decade. Imagine that, a small, lightweight system with the capacity to power a small lunar neighborhood. Earlier this year, in late January, NASA announced the completion of the first phase of the project, a significant milestone that brings us one step closer to realizing the dream of long-term lunar habitation. This phase focused on proving the feasibility of such a compact yet powerful system, laying the groundwork for the next steps. As we look ahead, Phase 2 is set to commence in 2025. This next stage of the project carries an exciting mission: to create a final reactor design for testing on the Moon. Yes, you heard it right. We're on the cusp of seeing a nuclear reactor designed for lunar conditions, tested on the Moon itself. The Technology Demonstration Missions Program Director within NASA's Space Technology Mission Directorate, Trudy Cortez, shed light on the significance of this project. She said, "The lunar night is challenging from a technical perspective, so having a source of power, such as this nuclear reactor, which operates independent of the sun, is an enabling option for long-term exploration and science efforts on the Moon." Indeed, the demonstration of a nuclear power source on the Moon is crucial. It will show that nuclear power isn't just a theoretical solution. It's a practical, safe, and reliable option for powering our future in space. NASA's mission is to ensure that nuclear power is a safe, reliable option for powering our future in space. As we look to the future, what does this mean for our exploration of the Moon and beyond? As we gaze upon the horizon of lunar exploration, the implications of these nuclear power projects are far-reaching. For one, they signify a shift in how we approach energy generation in space. The lunar nights, lasting for 2 weeks, are a challenge that even the brightest of our solar panels cannot overcome. The solution? Nuclear power, a source that is compact, yet robust, capable of powering our ambitions in the most inhospitable of environments. This development could inspire other countries to follow suit. The space race is no longer a two-horse race. It has become a global marathon, with nations around the world vying to stake their claim in the cosmos. As more nations step up their space programs, we could see a proliferation of similar nuclear power projects. This could lead to a new era of cooperation and competition, as countries vie not only for the stars, but also for the best way to power their journey. Yet, the importance of these projects goes beyond mere power generation. They are crucial for long-term exploration and scientific efforts. With a reliable source of energy, we can maintain a constant presence on the Moon, conducting experiments, mining resources, and perhaps even establishing permanent habitats. This is not just about visiting our celestial neighbor, it's about making it a second home. Moreover, the advancements in technology needed to safely and efficiently harness nuclear power in space could have far-reaching applications back here on Earth. Imagine a world where we can generate vast amounts of power from a small package without the need for constant sunlight or wind. That's not just the future of space exploration, that's the future of energy. The future of space exploration is bright, and it's powered by nuclear energy.